So you've got this amazing idea, right? It's just a file on your computer. But how do you actually turn that into something real, something you can actually hold in your hand? Well, today we're diving into the incredible world of 3D printing and what's called hybrid manufacturing. This stuff is completely changing how we make, well, just about everything.
You know, for centuries, making things has been a bit like being a classical sculptor. You start with this huge block of marble, right? And you just chip away and chip away everything that isn't the statue. That's pretty much how we've always done it. It's called subtractive manufacturing. You take a big chunk of metal or plastic and you cut it, drill it, carve it, until you get the shape you want. I mean, it works, but you can imagine it creates a ton of waste.
Okay, but what if instead of taking stuff away, we could just build things from the ground up? That one simple question really splits the world of manufacturing into two completely different ways of thinking: adding versus subtracting.
And that's the whole idea behind what most of us call 3D printing. In the industrial world, they call it additive manufacturing. It's totally the opposite of that, sculptor. Instead of starting with a big block, you start with, well, nothing. And then, following a digital blueprint, the machine adds material. Could be plastic, metal powder, you name it. One super thin layer at a time, building it up until, poof, the object is there.
So when you put them side by side, the difference is just night and day. Subtractive manufacturing carves away, leaving a pile of wasted material. Additive builds up, using only what it needs. But here's where it gets truly revolutionary. With additive, you can create these unbelievably complex shapes on the inside of an object. Imagine like intricate cooling channels woven through a jet engine part, things that make it way stronger and more efficient. There's just no way a drill or a cutting tool could ever get in there to make that happen. It's impossible with the old methods.
Now, all of this might sound like it's straight out of a sci-fi movie, right? But believe it or not, the idea of printing objects layer by layer has actually been kicking around for a surprisingly long time. So let's take a quick look at how this all went from pure imagination to actual reality.
Okay, you have to hear this. All the way back in 1945, 1945, a science fiction writer named Murray Leinster described a machine that, and I quote, draws things in the air with plastic that hardens as it comes out. I mean, come on, that is an almost perfect description of a modern 3D printer, but he wrote it decades before the tech even existed. Mind-blowing.
So that sci-fi dream really started to become reality in the 80s. In 1984, a guy named Chuck Hall filed this game-changing patent for something called stereolithography. Just 2 years later, he founded 3D Systems, and bam, the first commercial 3D printer was born. Then, fast forward to 1995, we get another massive leap, developing a way to do this with metals. That changed everything.
All right, so additive manufacturing sounds like the perfect answer to everything, doesn't it? Less waste, crazy complex parts, what's not to love? But, you know, like with any technology, it's never quite that simple. So yeah, what are the drawbacks? I mean, if additive is so amazing, why do we even bother with the old school methods anymore? Well, the answer really is in the details.
And this chart here lays it out perfectly. Additive gives you this incredible freedom with shapes and geometry. But because you're building in layers, the surface can be kind of rough and the precision isn't always razor sharp. On the flip side, traditional CNC machining is unbelievably accurate and gives you that beautiful, smooth finish. But of course, it's wasteful and can't make those crazy internal shapes. They're almost perfect opposites of each other, each with its own strengths and weaknesses.
This is where things get really, really cool. What if you didn't have to choose? What if you could take the creative, waste-saving power of additive and smash it together with the precision and perfect finish of subtractive, all inside the same machine? Well, that is the incredible promise of what we call hybrid manufacturing.
Okay, so how on earth do you actually merge these two completely different worlds? Let's get into the nuts and bolts of the technology that makes it all work.
The key to a lot of this is a process called directed energy deposition, or DED for short. The easiest way to think about it is like super precise robotic 3D welding. You have a machine with a powerful laser that creates this tiny little pool of molten metal on a surface. At the exact same time, a nozzle is blowing fine metal powder right into that pool. The powder instantly melts and fuses on, and you just build up your object bead by bead, layer by glowing layer.
And this just shows the two main ways that powder gets into the action. The nozzle can either surround the laser beam with a cone of powder, that gives you a really even distribution, or it can kind of inject it from the side. Each method is good for different jobs. Depends on what you're trying to build.
And it's not just the method, even the type of powder you use involves this really interesting trade-off.
If you look at this chart, see over on the right? Using a really fine powder gives you a much nicer, smoother surface finish. But swing over to the left, and you see that a coarser powder is cheaper and you can lay it down way faster. So it's always this balancing act. Are you going for quality, speed, or cost?
Okay, so we get the history, we get the science, but what does this new frontier of manufacturing actually look like when it's happening? What can it really do?
This is it. This is it in action. That's a complex metal part, literally being grown from nothing, glowing red hot as the laser fuses powder, layer after painstaking layer. And we're not just talking about prototypes here. This is being used to make final, mission-critical parts for things like jet engines and spacecraft.
And boom, here's a finished part. Just look at that insane geometry. This is where the magic of a hybrid system really shines. The machine might have built up the rough shape using that super-fast DED process, and then, without ever moving the part, it just seamlessly switches over to a traditional milling tool to machine the outside surfaces to perfect smoothness and incredible accuracy, all in one go.
And we are definitely not talking about little desktop machines here. This beast is the Mazak Integrex. It is a full-blown, state-of-the-art hybrid manufacturing center. It combines a super advanced CNC machine with a metal 3D printing head. One of these can do the job of 5 separate, older machines. Think about the savings in time, cost, and just plain factory floor space. It's a game changer.
So when you boil it all down, this is the crucial point. The hybrid advantage is massive. You can build and finish a part in a single machine. You can 3D print a part with those impossible-to-make internal channels, then machine the outside to an absolutely perfect tolerance. You can even take an old, worn-out part, add new material right where it's needed, and machine it back to its original shape. It's part creation and part repair, all in one.
This technology is just completely rewriting the rules of what's possible in manufacturing. It's blurring the lines between making something from scratch and repairing something old, between building a rough shape and creating a perfect finish. It really makes you wonder, doesn't it? If we can now combine building and perfecting in a single step, what are we going to make next?